හරි. අපි අද පොඩ්ඩක් වෙනස් දෙයක් කරන්න යන්නේ. We are going to start a different thing. So in the last week I hope that I taught you the very basic types of forces, including friction and many more. So Manugi, did you have proper practice in those things using the regular class videos as well? Manugi?
Yes, sir.
Did you have a proper practice including the regular class video as well?
Yes, sir.
Now I'm expecting that you to deal with any force related calculations easily or hard?
Easy.
Easy, na? Okay. Today I am going to give you a very simple thing. Like actually it took like 5 weeks in the regular class. Only the last week I finished that part. So from next week onward we are going to keep one step ahead of the 2025 regular class. Regular class එරවඩා එක step එකක් වැඩිපුර තියන්න යන්නේ ලබන සතියේ. So today we are going to equal the regular class. In the yesterday only I just finished that part in the 2025 regular class. So let's see how it is going to affect here. Now write a very big topic: work, energy and power. Work, energy and power. Work, energy and power. Work, energy and power. W equals to F into D. So you can understand this one was there in your O-level time even. The work amount is equals to force multiplied by the distance. So you can get the amount of work done using this equation. හරි නේද? Okay ළමයි? So what is the unit it is going to be? W equals to Nm. Unit is W is equals to Nm. Understand? Newton meter. So any alternative for this one can be taken as joules as an alternative unit for this. An alternative. Okay? Manugi?
Okay, sir.
Okay. So then we have to explain what is work. Work is the product of force and displacement. So there is no specific definition for work. Work is the product of force and displacement. If there is a force, there is no displacement take place. Like imagine like I'm just pushing this. But the thing is this does not move. That means I have done no work against that. Understand? I have only applying a force, but without doing any work. Work means you have to do something. So the ability to do work is known as energy. Now, like the subtopic, energy, 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 energy. So, what is the meaning of energy? What is the meaning of energy? Write the subtopic with the energy and the definition. The ability to do work is energy. Ability to do work is energy. So write this in a new line. Energy has multiple forms. Energy has multiple forms. ක්‍රම ගොඩක් තියෙනවා energy වල. Energy has multiple forms. Multiple forms. So what are the multiple forms there? You can consider it like, so chemical energy, thermal energy, write them. Chemical energy, thermal energy, nuclear energy, kinetic energy, potential energy, and etc. etc. Write this in a new line. But two basic forms studied under. Two basic forms studied under. Tell me, what are the two basic forms? Huh? What are the two basic forms? Write this. Potential energy and kinetic energy are the basic form, two forms. Potential energy and kinetic energy. Write this one in a new line. Potential energy, another subtopic. Potential energy. Potential energy. Now tell me, what is that potential energy? Huh? Potential. The meaning is energy stored, write the definition, in an object. Energy stored in an object due to change of position. Due to change of position. Change of position. Change of position against certain force. Against certain force. Okay. Now, can you tell me the many different types of energy, potential energies? Huh? Are you listening to me? Can you tell me any types of potential energy differences? Potential energies? Yes or no? Hello? What are the type of potential energies? Hello?
Chemical energy.
Nah, Daru. I told that different types of energy are like chemical energy, thermal energy, basically we consider like two types. Here the two type is potential and kinetic. In that one, I just explained what is potential. Inside that potential, like this, there are three basic categories studied in the A level. In the A level, there are many more, but here we are considering about these three only for A level. Number one, gravitational potential energy. Number one, gravitational potential energy. Number two, electrostatic potential energy. Number three, what is is it? Elastic potential energy. 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 Then write after kinetic energy. Sorry. So write this in a new line with the double star point. For the mechanics lesson, we only study gravitational potential energy, and elastic potential energy. Elastic potential energy. Elastic potential energy. Elastic potential energy. Now write this in a new line. Kinetic energy. Kinetic energy. Right. Let me know what is kinetic energy, please. මොකක්ද kinetic energy කියන්නේ? Write the definition in the
Energy
below.
produced by moving objects.
Yeah, energy stored in a moving object is known as energy stored in an object due to motion. In that way, because in a moving object, potential energy can also be there. So we have to write like the energy stored in an object due to motion. Due to motion, it's known as what? Kinetic energy. Okay. ඔය ටික තමයි අපි කරන්න තියෙන්නේ. So we have to go into that one, and today I'm going to finish types of energy firstly, then law of conservation of energy, and the elastic and inelastic collisions. No, I will have to take you that part later. Did we talk about momentum yet? No.
No, sir.
All right, I will teach momentum later after this one. So momentum, at the end of lesson of momentum, I will teach that part, elastic and inelastic collisions. So today my plan is to teach you this part, what? Types of energy, law of conservation of energy, and power and efficiency. And at the end of the day, if I have the time, I will teach you the momentum part. Okay. Hari. ඉතින් අපි ටක් ගාලා ඔයා දන්න කියන අපේ share board එකට ගිහිල්ලා වැඩේ කරමු නේද? Are you ready?
Yes, sir.
Okay. Okay, Manuki. Now write a subtopic: gravitational potential energy. Gravitational potential energy. Give me 1 minute. I will firstly share you the tute. I shared you the tute. So write the subtopic: gravitational potential energy. Right, okay. Let me know one thing. What is gravitational potential energy? You have the idea now. It is about gaining of energy due to change of position in gravitational field. Write the definition. Gaining of energy due to change of position in a gravitational field. Okay, now we know what is it. Work is equal to force into distance. So the gravitational potential energy should be equals to force is mg downward. You do a work against this weight. So mg into height. So it is mg h. Quickly copy this diagram to your book. Another, did you copy this one?
Done, sir.
Right. The next type of energy it is going to potential energy is, you can consider it like a potential energy due to what? Elastic potential energy. Write the next point, elastic potential energy. Elastic potential energy. Now write energy stored in objects due to change of shape. Due to change of shapes. At the beginning, force is 0. At the end, you may see that it has got some extension of x because of some force of F, right? So the distance is x. When one thing we know, W is equals to FD. So we are considering about the energy stored. What is the force here? The force is at the beginning 0, at the end F. So you have to go for mean force, because why? Can you remember in motion lesson we learned, if something start with the velocity of u and finish with the velocity of v, we consider mean velocity. What is the mean velocity meaning? U plus v over 2. In the similar manner, we have to go along with this one. So like this. So I can apply it like f plus 0 plus f over 2 times d. And we another thing we know, that is f is equals to kx. We just learned. And this displacement is also x. Displacement is also x. So once I just substitute this value, you can derive the equation of half k x to the power 2. This is how you find out the elastic potential energy of a spring. It can be a compression or a extension. ඇදුනත් තෙරපුනත් එකම කතන්දරේ. හරි නේද? හරිද?
Done, sir.
හ්ම්. හරි. half k x to the power 2. I hope you can understand this one.
Yes, sir. Understood.
Very good. Okay. ඊළඟට ලියන්න example එකක් ඔකට දාන්න ඕනේ නෑනේ. බොරුවට පොඩි පොඩි ගන්නන්නේ. Now right. Kinetic energy. Kinetic energy. At the beginning it's u. We can consider it like 0. In the end, it is just going to advance to v, some value of v, because of a certain constant force of f. Under that, this one may get accelerated under an acceleration of a, and the displacement between these 2 points is, I can consider like d. Right. So we know one thing, w is equals to f into d. Now it is becoming ek, kinetic energy. When you apply a force to a certain object, what is that acceleration and force relationship? We know that F equals to ma, according to Newton's second law. So it is like ma d, mad. Right. The thing is, I have to find out what is d here. So to find out d, you can just link what are the details you have. U you have, v, a and d. So the equation is going to be, you can apply v square equals to u square plus 2as, and this is 0. V square is equals to 2, sorry, a, I want to get a, sorry, whatever thing, a hari d hari denna ekeneko gatta nan hari, I'll get d here. D is equals to v square over 2a. Now going to substitute this one. Have a good look at ek is equals to ma times v square over 2a. A and a cancel off. A cancel off. Finally, you get the results. ek is equals to half m v square. This is how you find out the equation for kinetic energy. හරි. ඔයාලා දන්නවද ළමයි? මේ වැඩේ මේ ටික කරන්න. මම හරියටම පැය 3ක් ගත්තා. ඒ කරලත් මුට තේරෙලා නැහැ. ඒ කරලත් තේරෙලා නැහැ. ළමයි රෙගුලර් ක්ලාසස් වල ඉන්නෙම මාර හරක්. චූටි ගානක් තනියෙන් හදා ගන්න තේරෙන්නේ නැහැ. හැබැයි වැඩේ කියන්නේ හයි IQ ළමයින්ගේ ඔක්කොම හොඳයි, එක පැත්තක් අවුල්. මට ඒකයි තියෙන බය. මම බලාපොරොත්තු වෙනවා ඔයාලා නම් පිස්සුවක් නටන්න නැතුව හොඳට ඉඳී කියලා. හරි නේද?
done, sir.
ඕකේ. දැන් මම ඔයාලට ටියුට් එකක් එව්වනේ. ඒකේ අපි පොඩි ගණන් ටිකක් හදමුද? Wait. So you got this टियूट ने?
Yes, sir.
So just read these things. It include all the theory and the very basic background things and everything. Very simple ones. So there are a few examples like how the work changes with the angle and everything. Very simple. Can understand yourself alone because these things are really absolutely easy. Then the positive and negative term of energy is also there. These are very background theory, MGH with examples there. I want to check your very basic understanding. So these questions are really easy, very easy actually. So shall we try out this 10 questions? It is somewhere like 30-minute given. I can't give you 30-minute, but I will give you happily about 20-minute because for 2 minutes for one question each, it doesn't take 2 minutes for all the questions, but there are some bit hard ones. So I will give you 20 minutes for you to try with very basics of the stuff here. Things called power. That's called power. So what is the definition of power? Definition of power is the rate at work done. The rate at work done. Or the work done per unit time. Or work done per unit time. These two definitions are really important. So the amount of work is power is work done over time. So simply power equals to W over T. So W is in joules, this is in seconds. So this JS minus 1, or we can express that in watts. Okay. So this work done can be anything. the work done can be anything. You can write another triple star point. Work done can be anything. What is the meaning of that? So the power equals to W over T. Good example, the work done can be gravity. So it should be mgh. So you can substitute mgh. So the equation becomes what? Power equals to mgh over T. These are really examples only. You can't just write this one as a note. Just even a note, you can't rely on it. So the friction can be a work done against friction. How can it be? Then power equals to mu mg d over T. Can be anything. Electricity. So VI T. Power equals to VI T over time T and T cancel off. Power is equals to VI. මේ වගේ එක එක විදි වලට වෙනස් වෙන්න පුළුවන්. Can you understand it?
Yes, sir.
Okay. Or even a spring. How? Spring. Half kx to the power 2. When you convert it to an equation, p equals to half kx to the power 2 over 2t. මෙන්න මෙහෙම convert කරන්න පුළුවන් එක එක විදි වලට. දාගන්න ඕක example එකක් හැටියට. Can you just understand this?
Yes, sir.
Okay, now write another subtopic. Power due to power of a moving object in uniform velocity. Under constant force. Under constant force. It is not under acceleration. It is about what? Uniform velocity. Right. So what can you do? You know the equation, power equals to work done over time. And you know work done equals to F into D. Once you substitute that, you can get this one. Power is equals to F D over T. This looks ugly. I can rearrange F times D over T. What is this D over T, Ramya? What is that D over T? Hello.
Speed,
Displacement over time. Tell me quickly.
velocity.
Ah, that's velocity. The equation becomes F into V. I hope you understand this one. Me? Yes or no?
Yes, sir.
Okay. So there is a very simple exercise there. So you may just have a good look at the example C1. Few examples are there. So try efficiency. Wait. there are only two calculations. Do those two calculations. I removed most of the unwanted amount of work, and also I included some examples. So the question set span from this page to a few examples, and in the next page again what rest of the questions. There are like 7 questions altogether. You get a maximum of 15 minutes. What the heck? Seriously, words. Okay, your timer starts now. It's 15 minutes from here. ඒසීද කියලා මම එක්ස්ප්ලේන් කරන්නෙත් නැත් කියන්නේ තියරි එක විතරක් කියලා දීලා හදාගෙන යනවා එක්සැම්පල් ගණන් ටික දිහා බලලා ඉතන ලේසි දේවල් හිතා ගන්න බෑර ලෝ IQ සෙට් එකට ඒක අමාරු කියලා කමක් නැහැ දැන් මේක වීඩියෝ වචස්ලාට පොඩි හානියක් වෙනවනේ මම එක්ස්ප්ලේන් කරේ නැත්තම් so I will explain a constant force 2000 pulls a crate along a distance of 10 meter in 50 seconds so the power is equals to work done over time work done is equals to F into D over time so F is 2000 multiplied by 10 over 50 so it is like 4 times is like 000 is 400 watt very simple a high starter rate at an electric motor for 3,300 kilogram vertically at a steady speed of like this much. The frictional resistance can be taken like 1,200. What is the power required? So you know one thing, it is under some kind of constant force. One thing is mg, the other one is frictional force altogether and moving with velocity of v. We had a really general equation. We had it's here. See, P equals to F into V. So the equation is P equals to F into V. So the F is a combined stuff. It is like 300 times 10 because it is mg, right? Plus the frictional force 1200 times velocity of like 0.2. 4200 times 0.2 it is like 2 times 840 what did you get these two answers correctly?
Yes, sir.
Very good girl yourself alone no? That's the reality how easy these lessons are a force of 5 Newton moves a 6 kilogram object along a rough floor at a constant like 2.5 ms minus 1. How much work is done in 25 seconds? Rough floor. So the force is 5. Then the stuff is going to be like distance, sorry, power, sorry, force into velocity. It is 2.5. 5 times 2.5 is going to be 12.5 watt. Oh, sorry. Yeah, firstly, amount of work done. Work done on the time. 5 Newton, 25. Work done equals to into T 5 times 2.5 times 25 is the amount of work done. So this is the power. Work done is going to be like 12.5 times 25. 25 times 10 is 250, 300 and 0.5, 312.5 joule. So these are the two works. Now in the next one, how much electrical energy in kilowatt hours would a 60 watt bulb use in 60 days in a life of steadily? Firstly, you have to find out power into time. So it is 60 watt in 60 days life on steadily. 60 days per a day, 24 hours. Because into time, no, 24 hours into 1 minute, it's going to be 60. So converts to seconds again into 60. You just need to convert it in the kilowatt hours. Yeah. How to divide in thousands to convert to kilowatt. Okay. So the amount of energy is 6 times 4 times 24 is the amount of energy used. So you will have to again divide it by this the amount of energy. No, wait. Again, you have to divide it by to convert to hours. 60 and 60 gone. How many kilowatt hours will be there? You don't want to multiply this by time thingy because you are finding it in hours, only 24 hours. 36 by 24 over 10 is the amount of kilowatt hours you will have. So 36 times 24 is like 36 times 20 is going to be like 360 and 720, and 36 times 4 is 144. 720 and 144 is like 864. Sorry, 600, 700. Yeah, 864 over 10. It is going to be 86.4 kilowatt hours. Did you get the answer?
Yes, sir.
Okay. Now the next one is 12-volt car battery is found to be capable of storing 2 kilowatt hours of electrical energy for a certain electric car necessary if it is necessary to develop 10 kilowatt hour to power to drive 20 kilometers per hour. Okay. Suppose that the car such 10 batteries results in 10 times the energy. How long hours could be run all of 10 release their energy? So it says like drive at 20 kilometers per hour. Okay. Power equals to, so the force multiplied by velocity. Wait. Energy equals to work done over time. So the energy is 10 kilowatt to 20 kilometers multiplied by any work done over certain period of time. Any work done over certain period of time. When you have such 10 batteries, 10 kilowatt, 100 kilowatt is equals to same speed multiplied by time. It is going to be the same amount of wattage consumed multiplied by certain time of t dash. So it is t dash is equals to 10 times t. You can only find it out in this way. How far kilometers can go in a 10 batteries if the fully charged. So in that case, we can't find it because the thing is we don't know the all right, it says 20 kilometers an hour, so you can run 200 kilometers, right? 200 kilometers. Now the power output of an engine is 3000. How much is work done in 20 seconds? Work done equal to power into time. Power is equal to 3000 multiplied by 20 seconds. It is going to be 60,000 joule. Now in the last one, the efficiency of engine is 30%. What is the energy supplied engine in 20 seconds to the engine? Output, no? So the efficiency is what? Out, E out over E in multiplied by 100%. E in is out over efficiency multiplied by 100. It is like out is 3000. Sorry, 60,000. And efficiency is like 30%. How to multiply it by 100? Is 2000 by 100, 200,000 joule is the amount of energy supplied. What is the power supplied to the engine? It is going to be 200,000 divided by 20. 20 and 20 cancel off 10,000 watt. මේ ප්‍රශ්න ටික මම හිතනවා හදන්න නැති කියලා easy. එහෙම නේද?
Yes, sir.
Yeah. Was that easy or hard?
One question was hard and the others were easy.
Yeah. In the first attempt, it is more than enough. So there are very big theory here. So you may read these things at home very carefully and can learn how the type of energy changes. These things are very simple that you can easily understand. Gravitational potential energy with units and how does it change everything. And with few examples, read these examples very carefully and thoroughly. Try to draw these diagrams on your books. And the energy as a scalar quantity, everything, it doesn't matter. You go in this path or this path, it has the same energy because of the mgh difference. Only you consider the vertical height, whether the path is like this type of path, up and down type of path, whatever, it doesn't matter as long as you reach to some where finally it is a so energy is a scalar quantity. And examples are there. So finally this is the same thing. Kinetic energy I explained you, very simple. So let's try these questions. After that we can have an interval. Then I will teach you the law of conservation of energy very simply and give you a very new big worksheet as well. So let's try these very simple questions that I have given here. The activity is a little bit longer one, but the questions are really easy. So the maximum time allocation is no more than 15 minutes for you. Sandeep sir told me that you are not joining physically, sorry, babe, in the classes for him.
No,
Is
sir,
that
I
true?
can't.
He told me you have like school or something and
No,
then you
sir,
can't join
only
something.
1 week I couldn't join. Because
Ah, only for
yeah,
1 week.
sir.
That's what. He told me that it's like a continuous thing.
No, sir, only for 1 week.
Oh, that's what. Okay, okay. So let's start. Your time is there.
In progress.
So I will just explain these things for a very little while. So calculate the kinetic energy of a 45 gram golf ball traveling at 20 ms minus 1, half times 45 into 10 to the power minus 3 because it's grams, multiplied by 20 by 20. So it's going to be like here 10, 1 0 gone, another 0 gone. So now it's going to be right 2 times 45 divided by minus 1, 90. So 9 joules here, 40 ms minus 1, definitely 4 times that, but I will explain you. Without calculating, I can say the answer 36. The reason is 45 times 10 to the power minus 3 times 40 multiplied by 40. 0, only 1 remaining here. Right, K2. Right. 45 times 2 is 36 and minus is going to be 360 and minus 1, that means it is going to be like 9. 9 times 4 is 36 joule. I told you, no, because if the speed increased by a factor of 2, velocity increased by a factor of 2 to 2v, so v square means 2v square. So that means what? Your factor of, you have to multiply it by a factor of 4. If it increased by 3, what is the result then? Can you guess what is the result? Here it is the 3 time. Without doing that way, we can do why? 3 to the power 2 means 9. So 9 times the initial value of 981 joule. Did you get these answers? Can you understand this method? Because for solving MCQs, you may need that. So the v to the power 2 means you have to multiply it by like 3v to the power 2. It's going to be 9v to the power 2. So the multiple factor is what? 9. Can you understand?
Yes, sir.
Okay. For solving MCQs, you have to have that one. That next one is when, wait one. An object mass 50 kilograms speed up from 5 meters to 10 meters per second. What is the total kinetic energy before accelerating? Before accelerating is like half into 50 into 5 by 5, 25. So 25 by times is 125, 625 joules. Here, what is the total kinetic energy after accelerating? So half into 50 into 10 by 10, 25 by 100, 2500. See, it is 4 times multiplication. Why? It is 2v to the power 2. How much work is done? Increase the kinetic energy of the car. Delta E equals to 2500 minus 625. When you subtract 600, it's going to be like 1900. 1875 joules. Very simple. At the moment when shot putter release 5 kilogram shot, the shot is 3 meter above the ground and traveling at 15 ms minus 1, reaches the maximum height 8 meters above the ground and then falls to the ground. Air resistance negligible. What is the potential energy when left the hand relative to the ground? EP is going to be mgh. It's going to be like 5 times 10 times 3. It is going to be like 150 joule. Very simple one. The next part is like, what is the kinetic energy of the shot part release in the hand?
15 ms minus 1. Five times 15 is 75. 75 by 10 is like 750. This is going to be like 200, 375, 1000. Yeah, 1125. Divide by 2, sorry. So it is going to be like 565. What is the total energy of the shot left the hand? Total energy is 565 plus the previous one. What is that? 150, 150 together. So it's going to be 715 joule. What is the total energy of the shot at reach the maximum height? Total energy should be the same value according to the law of conservation of energy. What is it? The 715. What is the potential energy at the maximum height? Potential only mgh. That's going to be like 5 times 10 times height is like 8. 5 times 8 is 40. 40 times 10 is 400 joule. What is the kinetic energy at the maximum height? You have to subtract it from here to from the total. EK should be equals to 715 minus 400. So it is 315 joule. What is the kinetic energy when just as it struck the ground? So it will travel something furthermore downward. So your total energy 715 should be add up with 3 times 5 times 10. 15, another 100. Wait. No. Totally convert to 715. No potential then 715 joule. This is the very basic to lay off the foundation for the law of conservation of energy. So let's have an interval of 15 minutes and rejoin. Then we can just do the law of conservation of energy today and finish up the lesson very happily ever after. So just let's have 15-minute break. Ane, girl.
Okay, sir.
It's a new lesson, right? The law of conservation of energy. So first of all, just read this part. Just quickly, just take like maximum of 10 minutes. And read it until to the page number 24 very quickly with the example. Okay. Then I will explain you what is law of conservation of energy with notes and some really good questions. Okay, let's start quickly. The most important part in entire physics, most beautiful part, is the law of conservation of energy. Law of conservation of energy. This is the most important part, right? So in this case, I want to explain you one thing. The energy cannot be destroyed or created. It can only convert from one form to another. So you can write the definition of this one if you want. the total amount of energy in a system, the total amount of energy in a system is constant it can only converted from one form to another. It can only converted from one form to another right. Imagine like example number 1. You drop something directly from a height. Drop something directly from a height to a ground. Reaching to with velocity of v and having a height of h. At the beginning, we can consider like velocity is b0. At here, height is 0. So here there is a potential energy that of mgh. And you can clearly see that with the velocity, there is a kinetic energy that of half mv square. So here the potential kinetic energy is 0 because the velocity is 0. Here the potential energy is 0 because height is 0. So as I told you, the law of conservation of energy means the initial energy should be the final energy. Initial energy should be equals to the final energy. Initially it was this one and the finally it is this one. So you can merge these two things together like mgh should be equals to half mv square. Just leave it, don't cancel m and m, just leave it because you to understand potential energy should be equals to what? Kinetic energy in this case. Understood the concept?
Yes.
Copy this diagram very quickly.
Done, sir.
Right. Next part. It can be this way as well. Now imagine like if it is sliding down like this type of path, you can see that energy is a scalar quantity, but the height, vertical height is a vector. So EP is equals to mgh. Here the height is 0. So the EP is 0. Here k is 0 because v is 0. Now here there is a velocity of v. If k is there, as the same as of the previous case, even though the shape is different. Now let me just make the shape even different. This type. It doesn't matter since the vertical height is still the same. mgh should be equals to half mv square in this case as well. Understood?
Yes, sir.
Yes or no?
Yes, sir.
Very good, girl. Now imagine against friction. Work done against friction. Right. Now I am going to get something like that type of curve. In the curve, this part is frictionless, mu is 0. That means friction plus here there is the potential energy. I'm not going to explain that again. Here this one converts completely to what energy? Kinetic energy because of velocity v half mv square. Right. Now the flow becomes rough. So the stuff will stop somewhere here. Why? Because it has to do a certain work against what? Friction. D is there. So there is a constant of mu there. So the amount of work done is there against friction. What is mu mg d? So the work done finally in the first half, first case, what is it? mgh equals to half mv square. In the second case, half mv square should be equals to what is mu mg d. So you can see these two terms are the same. Then you can link these two together. ඒක තේරුම් නැද්ද? See whether you can understand it or not. Can you understand or not? If not, please let me know. I'll explain you one more time.
Can understand.
Can or can't?
Can understand.
Okay, copy that one too. Because these two terms is still the same, you can equal these two equations very easily because there is a common term. Are you still copying or copied?
Copied, sir.
Copied. Very good. Now, another example. So let me explain you. As I told you, when you compress certain spring, it will withstand some kind of x distance. Energy EP is equals to half kx to the power 2. After, you can release this. Spring extend back to original form, and this one will just move with velocity of v. Here the EK kinetic energy is 0. Here EP is 0 because the extension came back to original form is 0. But there is a kinetic energy. What is it? Half mv square. So can you understand, if according to the law of conservation of energy, this potential energy should be equal to this kinetic energy. So the result is going to be half k x to the power 2 should be equals to half mv square. Isn't that
Yes or no? Ramai?
Yes, sir.
Okay. Now, is there anything really hard to understand?
No, sir.
No. Okay. Would you believe that? Would you just believe that we have just gone past 2025 general A level batch within how many days? How many days did we do the class? Huh? How many days did we do the class? Hey,
Yes, sir.
yeah. How many days did we do the class?
Wait, I have to count.
How many? ඔයා ගණන් කරනවද?
6.
Within 6 days, we have gone just past regular 2025 A-level batch with full understanding. Everybody in this class, even the talkative ones, non-talkative ones, and the video recording watchers, and everybody seem to be really happy with this because why? Clean and clear, very fine explanations with no unwanted time spending. කිසිම කාලනාස්තියක් නැතුව අපි මොකද කරේ 2025 regular class එකේ කරලා තිබිච්ච ඔක්කොම ටික දවස් 6කින් හොඳටම තේරෙන්න කරා. තේරුණාද නැද්ද කියලා කියන්නකෝ මේ ටික.
Understood, sir.
Understood this one well or still halfway?
Understood, sir.
සාමාන්‍යයෙන් මම දන්නවා මේ ළමයි හැමෝම මට worksheets ටික කරලා එවනවා මාර ලස්සනට. The best thing is none of you have ever been in a regular class to this extent. මේ දුරට කිසිම class එකක ලංකාවේ තාම කරලා නැහැ. කරනවා bypass යනුන් ඉන්නවා. ඒ කියන්නේ මැද තියෙන it is like units and dimension, measuring instrument, then vectors, linear motion, projectile motion, after that static equilibrium, then Newton's law of motion, momentum, energy, power stuff, and finally law of conservation of energy. This is how the flow chart. If you learn this way, you can clearly understand. But in normally, they do something really stupid. Instantly, they stop it from here. The law of, so they don't go for this. These things are really uncatchable for most of the low IQ students. So what do they do is instantly jump to circular motion and rotational motion and just stay some there. Actually, they don't do the rotational motion, even circular motion. Then instantly come. Then after that, quickly, slowly come to these things and finish. None of the classes in Sri Lanka have done this extent in the regular classes. But I go along the steps because if you just miss any of these crucial steps, you won't understand any of the future lesson. But in this class, I happily finished within 6 days, all the really very easy and extremely essential steps. In the next week, in the regular way, අරවගේ bypass way නෙමෙයි. In the next week, we are going to learn circular motion and rotational motion in the regular way. I am happy to say that we are going to finish entire circular motion, sometimes half of rotational motion in the next week. But in my regular class, even I start circular motion, I will spend like long time to explain circular motion and rotational because those students really want me to even slow down. I don't know why. Only one student, she's also in this group, common one. That's girl called Sharina. She asked me, sir, can you speed it up at least like 5 times more than this? That's her request. මම කිව්වා ඔයා කියන විදිහට 5 times නෙමෙයි මම මේක නිකන් හරි 1.5 times speed කරොත් එහෙම මුන් ටික suicide කරනවා කියලා කොහෙට හරි කියනවා.
පුදුම මොහොත ළමයි ඉන්නවා මට හිතා ගන්න බෑ. They don't spend time to study, that's why. It's not the brain capacity problem. They don't spend time. They spend time in unwanted things. They'll have wasted their very valuable, important time on TV to shows and like YouTube and Instagram and chatting with the student, other fellows for none, spending time in gaming. Then they don't have time to solve some kind of really tough and hard questions. They really want us to teach with the very simple questions. සර්ගේ ප්‍රශ්න හරි අමාරුයි සර් එකෙක් කියන ඕල්ලේ weirdly hard වෙන කිසිම කෙනෙක්ගේ ටියුට් වල මෙච්චර අමාරුයි වනේ හරි එක්සෑම් එකේ ලේසිව දෙනවා කියලා හිතන්නේ in the exam they find like very simple question very easy ones මගේ අම්මේ නෑ එක්සෑම් එකේ දෙන්නේ ආයෙත් ඉතින් හේදිලා යන්න දෙනවා හැබැයි ටියුට් එකේ තියෙන්න ඕනේ easy ඒවා එක්සෑම් එකේ දෙන්නේ hard ඒවා කියලා දන්නවා එන සිලබස් එකක් කව කරන්න තියෙනවා කියලා දන්නවා හැබැයි උන්ට ඕනේ අර චූටි චූටි ගණන් හද මාස ගානක් හිමින් යන්න කොහොමද ඔබ කරන්නේ ඒ විදිහට ඔය ස්ලෝ එකේ කරොත් කියන්නේ යාළුවා අන්තිමට වෙන වැඩේ කියන්නද අන්තිම මාස 6ේදී සර්ලාගේ තියෙනවා ලෙසන් 5ක් 6ක් කව කරන්න පැය 8 7 හෙන දිග රෙකෝඩින් දානවා පුළුවන් නම් බාදාකට දාගෙන ඉන්න කියලා සතියකට දෙනවා පැය 20ක විතර රෙකෝඩින් ඔක තමයි කරන්නේ ඉතින් මේ මිනිස්සු හරි මෝඩයි ළමයි ඇත්ත තේරුම් ගන්න කැමති නෑ මම නම් ඉතින් පව්වැඩ කරන්න කැමති නැති නිසා suitable speed එක යනවා නමුත් හිතා ගන්න පුළුවන් නේද අපි මේ දේවල් regular class එකේ අවුරුද්දකට ඔන්න මෙන්න තව මාස දෙකකින් අවුරුද්දයි it's almost 1 year 10 months but we did within 6 days 6 class days හිතා ගන්න පුළුවන්ද next week we are going to get really head start යාළුව පහු කරනවා circular motion ඉවරම කරලා අර බලන්න එහෙම ඉවර කරොත් එහෙම එක දවසින් circular motion උම්මට නඩු දානවා හරි එතකොට යාළුව දවස් 7න් පහු කරනවා මාස 10කින් කරන වැඩි ඔන්න ඔකයි මේ high IQ class එකේ වෙනස කිසිම දෙයක් රෂ් කරේ නෑනේ හරි ලස්සනට කියලා දුන්න අවශ්‍ය දේවල් ටික විතරයි වෙනස කර තියෙන අර බබා වගේ ඔළුව අතක ගාලා හැඳි ගගා කරේ නෑ කිසි දෙයක් අර ළමයිනුත් රෙඩි නම් ඔය වැඩේට රෙගියුලර් ක්ලාස් එකේ මීට වඩා පොඩ්ඩක් ස්පීඩ් කරලා වැඩිපුර ගණන් ටිකක් හදලා කරන්න පුළුවන් අමාරු ගානක් හදපු ගමන් මුන්ට මේ කිරිපණු ගාය හැදෙනවා හරි ඕකේ දැන් ඉතින් අර එවපු hard work sheet එක කරන්න තමයි තියෙන්නේ I sent you one okay midweek worksheet 27 මම මේ regular කට්ටිය එක කරපු එක මේ ඊයේ රෑ කරපුවා මම කිව්වා බොරු නෙමෙයි නේ in the last night we did this එයාලට තිබිච්ච ප්‍රශ්න ඔය හරි මේ සෙට් එකම කරෙත් නෑ මොකද මේ ටිකයි එයාලට ගෙදරදි කරන්න දුන්න එකක් හරි ඉතින් අපි try එකක් දාමුද හානේ okay lamai let's do the first 2 questions here I will give you maximum of 12 minutes for all 2 questions අර මිනිස්සුන්ට මම එකකට පැය කාලක් දුවෙත් දුන්නා කමන්නේ 12 minutes for both the questions right let's start a pendulum consisting very small heavy ball of mass simple at the end of a string is L and released from a horizontal position. When the ball is at point P, which is the angle of theta from the horizontal as shown. Right. In the space below, draw a force diagram showing that all the forces acting on the ball at P. Identify each force clearly. One is the mg force, other one is the tension here, tension of the string. So determine the speed of the ball at P. So you can find out the amount of height it has just fallen through. How? When you draw this triangle, it is just L. This one is theta. So the other part you don't want to consider now. Here it is like the height of h. So the what is this side? This side is opposite side. This is the adjacent side. Sorry, yeah, adjacent side. And this one is hypotenuse L. So the opposite side of hypotenuse is sine theta. Sine theta is equals to the height over L. Height equals to L sine theta. So the height difference, when we know the height difference, we can find out mgh. That should be equals to half mv square in terms of the law of conservation of energy. M and M cancel off. So V can be root gh. So the velocity is going to be root 2g, h is L sine theta. This is the equation for finding out the velocity. I think you can understand this well because it is not a very big deal. Did you get this answer alone? Hello?
So
Hello?
one I couldn't.
Huh?
One answer I couldn't get along.
Which one? The last one?
Yeah.
Because you didn't think of this trigonometry here. Simple trigonometry. The best thing is, oh my god, you did like local, no sorry, edXL level, na?
Excel always.
Yeah. In edXL level, don't they have trigonometry in mathematics? Or mathematics?
Yes,
Huh?
we have.
Then
We
you know
have.
this one. Then why didn't you go for this finding h? When you draw this triangle, you can see it is a right angle triangle, and the L, same L comes to here because that's the length of the rope. So you can easily find out the height. Tension, to find out tension, we have to wait for the next week. There is an equation called mv square over r. V is this one because this is called the centripetal force that should be equals to the tension. So this part we don't know yet. We have to wait for the next week to learn that centripetal equation. But after telling the equation, you can understand V square means the root cancels off 2g L sine theta divided by R is also L. L and L cancel off. So well, F will be 2mg sine theta. Make a we didn't do that part even in regular class or irregular class, whatever the class we didn't do. A 2 kilogram block is released from rest at the top of curved inclined shape as a quarter of the circle radius r. The block then slides onto a horizontal plane where the finally comes to rest of the 8-meter beginning of the plane. The curved incline is frictionless, but 8 Newton friction is on the while sliding the horizontally. Determine the acceleration of the block while it is sliding along the horizontal plane. So 8 Newton, we know the mass. So the F is equals to ma is the force. So the F is known. What is it? 8 Newton. M is 2 kilogram. Acceleration is very easy. 4 ms minus 2, very easy. How much time elapsed block is sliding in the horizontally? So we know the acceleration, it is a deceleration because it's a retardation. Wait. Right. We don't know the V. Finally, it comes to 0 at here. Acceleration is there, -4. And distance is there.
V equals to U plus AT, but time we don't know. Sorry, time is the one we have to find out. V is 0, but you don't know. So we can use this one. S equals to UT plus half AT square. S is equals to 8 meter. Half into A is like 4 times T to the power 2. T square is going to be equals to 4. T is just 2 seconds. You know that part. So using that one, you can find out the initial velocity at the beginning. How? V equals U plus AT. 0 is equals to U plus A is like minus 4 times 2. U is equals to 8 ms minus 1. We have to find out initial velocity because then you can find out the kinetic energy here. That should be equals to the potential energy here. You have to see now it is the radius. The radius is the one comes to here. So that is the same height for this part. That's the radius height. So how can we find? Have a good look at. M G R is equals to half M V square. M and M cancel off. R is equals to V square over 2R. So sorry, 2G. I just found 8 times 8 over 2 times 10. It is just 4. 4 times 8 is like 32. Wait. 32 over 2, 10, it is like 3.2 meters. Very simple. It's a very simple answer. Now I think you guys understood it. Huh? Right. So we have finished this part so far. You can just deal with these things like in the thing I have done in the last class. Similarly, so try these things and send me answers. We have almost gone past our regular 2025 A-level batch. So are you ready to deal with these things and send me the answers? Huh? So within 6 days, you have just gone past 2025 regular batch. Are you happy about that or unhappy? Guys? Hello?
Happy.
Okay. Let's wind up the class for today. God bless you. Bye.
Bye, sir.
Okay, bye.